Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have question 4. It says the flow diagram below shows how various organic compounds can be prepared using compound P as starting reagent, right? And then we have the flow diagram here, as we can all see. Then the first question here says, write down the meaning of the term hydrohalogenation. So for 4.1, we're going to have what is hydrohalogenation. We say this is the addition reaction. The addition reaction of a hydrogen halide. So a hydrogen halide, we are talking about either hydrogen bromide or hydrogen chloride. Addition reaction of a hydrogen halide with an alkene. Then 4.2 says write down the structural formula of compound Q. But if you can look at all this, we don't have anything for compound P, we don't have anything for compound R, but we don't have anything for compound S. But then what we have here is we have the after the hydrohalogenation, we have this compound here. So this is CH3, CHCl, CH3. Now what we know about this question here is that every compound here will have to maintain the same number of carbon atoms. So we only need to find one structural formula or one condensed formula in order to determine the other compounds. So now that we've located that compound there, that means also compound Q must be made out of the same number of carbon atoms as this one here. So let's count the number of carbon atoms. We have 1, 2, and then 3 there. So this has 3 carbon atoms. So that means compound Q as well must have 3 carbon atoms. But then remember above there, we mentioned that hydrohalogenation is an addition reaction, right? Now let's make use of this SSS, USA, and SUE. Now this means saturated to saturated is a substitution reaction. Unsaturated to saturated is addition. Then from saturated to unsaturated is elimination. Now we know that addition reaction is from an unsaturated compound to a saturated compound, which tells you that compound Q here has to be an unsaturated compound. And the only unsaturated compound that we have must be an alkene. As we can see here, this addition reaction is a reaction of a hydrogen halide with an alkene. So this here compound Q has to be an alkene and then reacting with the hydrogen halide to give us a what? To give us a haloalkane, which is a saturated compound. It has single bonds between its carbon atoms, right? So now that we have discovered that compound Q is an alkene, it is an alkene that has how many carbon atoms? It must have 3 carbon atoms. Now, what is an alkene with 3 carbon atoms? We know that it is propene. So there we have our double bond, and then just fill in the hydrogen atoms. Make sure that here you only fill enough for the carbon atoms. Remember, the carbon atoms can only take up to 4 bonds. So make sure that you maintain that number 1, 2, 3, 4, 1, 2, 3, 4. So this here is correct. So we have our structure just like that. Now let's move to 4.3. It says reaction 1 is an elimination reaction. Now 4.3.1 says write down the type of elimination reaction. Now we have discovered that this here is an alkene, but looking at this molecular formula here, we can see that this one obviously has to be an alkane. Now, what elimination reaction do we know that that produces the alkene and the alkane? Now, the only elimination reaction that produces an alkene and alkane is a cracking reaction. Cracking elimination reaction. This is where we take a long chain alkane and then we form a short chain alkane plus an alkene. So this is the only elimination reaction that will have your product as the alkene and the alkane. So we say that is what? Cracking elimination reaction. Right, so just cracking like that. Remember, we have two types of cracking reactions. It's the thermal cracking and the catalytic cracking, but you did not need to be specific here because there is nothing to show whether it is the catalytic one or the thermal one. Now let's move to 4.3.2. It says molecular formula of compound P. Now, how do we find the molecular formula of compound P? Now, all you have to do, remember, we've already discovered that our alkene here is propene, which has a molecular formula of C3H6, right? From this one, 1, 2, 3, and then 1, 2, 3, 4, 5, 6. Now, we know that a cracking reaction is always balanced. Left-hand side is always balanced to the right-hand side. So that means the only way we can find compound P here is by adding the number of carbons here in the right-hand side and also the number of hydrogens. So that means taking 3, adding it to 5, this will give us how many carbons? 8. And then taking 6 and then adding it to 12, this will give us how many hydrogens? 18, right? And that becomes our molecular formula for compound P. So this here is called what? Octane. Then let's go to 4.4. 4.4 says write down the IUPAC name of compound R, right? So compound R, this is formed through the process of bromination, right? So bromination is also another addition reaction whereby we are reacting with Br2, right? We are reacting with 2 atoms of bromine. So now what will happen? Already we have this here. So that means if we are reacting it with those bromine atoms, the double bond will have to break in here and then opening up for a reaction there. The bromine atoms will have to come in here. Remember, this is an unsaturated compound, meaning that it can break into 2 air spaces that can accommodate those 2 bromine atoms. So this is Br here and then Br here. And now what they're looking for is not the structural formula, right? We must find the IUPAC name for this. So what is the IUPAC name? Counting from here, this is 1, 2, 3. So this becomes 1, 2, dibromopropane, right? So this is the IUPAC name for compound R. Okay, now let's proceed to the other questions. Now 4.5 says for the hydrolysis reaction, write down the balanced equation using structural formulae. The hydrolysis reaction here. Now we know that a hydrolysis reaction is a substitution reaction, which means this will be from a saturated compound to another saturated compound. Right. So what we are supposed to do here, using structural formulae 4.5.1, we want to have this structure here. And then now the second carbon is bonded to a hydrogen and also bonded to a chlorine there. And then we have the third carbon bonded to 3 hydrogen atoms. But since it's hydrolysis, we know that it has to react with what? Water. So let it react with H2O. Then it's supposed to give us what? Now, since this is a substitution reaction, we know that what will happen here is that the chlorine will be replaced by the OH here. So we are forming an alcohol. Remember hydrolysis, we form an alcohol. So this is what we're going to have now. In the place of Cl, now we have the OH there. And then just like that. But then remember, we don't just throw away that Cl. It needs to react with this remaining hydrogen here to give us our byproduct. Byproduct H Cl, not HBr. Remember, it's chlorine there. So we have our byproduct as hydrogen chloride. So this is what happened, guys. We just mainly replaced the chlorine with the OH, then took the same chlorine, reacted it with the remaining hydrogen here to form a byproduct, hydrogen chloride. This is what we call an inorganic byproduct. Okay, then 4.5.2 is now saying, give us two reaction conditions. Now we know for a hydrolysis reaction, because we are reacting with water, we need excess water. So excess H2O, and again, mild heat. So that's how you were supposed to tackle this question here, for a total of 15 marks. So those are your organic reactions. Make sure, guys, that you do not leave any mark to charity. Use your notes, guys, to practice. All the reactions and the reaction conditions are just there on that document. So make sure that you make use of that document, memorize, and just practice those until you can understand. Right. Then with all that being said, guys, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And then also, if you are watching these videos from Facebook, please like the page and also follow the page. And then most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.